God. Solving that by just giving everything a really shitty look. That kind of makes everything look consistently bad.
Why hello there! My name is Andrew David and welcome back to Game Baking. In January I participated in a tiny local game jam called the McGame Jam, hosted by the student body at McGill University but open to local non-students as well.
The theme.
The theme for this one was, I forgot. What was the theme already? Unexpected consequences. Right, that's how unmemorable that one is. So the issue with this theme is that it's a little too literal. This makes it pretty difficult to interpret in ways that are different than how the other participants would. Players perform an action or input and, well, an unexpected consequence will or might occur. How else can this be interpreted? The thing I try to always keep in mind with game jams is that the first idea that comes to mind when reading the theme is probably the exact same idea that came to mind for the majority of participants. And the first interpretation you think of is probably also the most obvious one.
Thanks, Captain Obvious.
So I usually write down as many interpretations as I can think of, mostly to get the obvious ones out of my mind, and force myself to come up with others. Same with game ideas. But for this theme, it was hard to think of even just two interpretations, so I just went with the obvious one and figured I'd make up for it in the game design department instead.
That's a great idea!
The concept.
I came up with a few ideas for this one, but none were really that great. The livestream chat helped out a bit as well, which I guess is idea crowdsourcing, which might be cheating, not sure. I figured, what can I do to make unexpected consequences fun rather than frustrating? Usually, if the player expects a certain outcome from an action or input, and something different happens, it can be pretty annoying. I didn't want this to happen with this game. I knew I wanted to focus more on the consequences aspect over the unexpected. So rather than doing a game where your controls or the state of the game unexpectedly changes, I wanted the consequence to be a little more controlled, serving as a punishment rather than a random event. So what did I come up with after a bit of brainstorming? This.
Oh my god, now the hand movement is inverted. Oh my god. His eyes on fire. It works.
So, before I specifically discuss the idea, here's how I ended up implementing the theme. You have a set goal with a fixed amount of attempts at that goal. Every time you fail an attempt, you get punished. That's the consequence part. You know the punishment is coming, so it's not frustrating. But which specific punishment gets applied is where the unexpected comes in. The game will have a whole collection of different punishments to serve, so you never know what you'll get. And on top of that, here's a quick secret on how to turn potentially frustrating punishments into fun. Chaos.
Chaos control!
The punishments in the game stack up, making it more and more chaotic. Chaos can lead to new and exciting experiences, keeping the game fresh and adding an extra layer of challenge to the game, which, in turn, makes the game fun. The concept is essentially just Mastermind. You know, the classic puzzle game, Mastermind? The game where you have to guess a sequence in both order and color. And every time you guess a sequence, you're told whether the colors you picked were wrong, right, or right but in the wrong position. Using those clues, you keep guessing until you guess correctly, or run out of turns. For Calamity, I took the concept of Mastermind, but gave it a fantasy twist. The aim is to concoct an antidote potion using various ingredients, and every time you guess wrong, a new curse is triggered, affecting either your controls or the camera. And of course, the curses stack.
The meat.
Day 1. I started a few minutes before the jam to set up my environment. I was working on this one solo, so I knew I'd need a bit of help from some tools and assets I've purchased from the Unity Asset Store over the years. I started a new scene, put in a Cinemachine camera, a sky gradient, prepared my usual code structure, and wrote some very generic high-level scripts like a game manager, a player controller, a player model, and some helpers like the persistent singleton, and some extension methods that I commonly use. In case you're curious, here's a quick breakdown of how I usually handle my code structure. First, I've got managers. These are high level and they have controllers and factories as properties. They're there to keep track of everything, listen to specific events, and trigger controller methods. I try to have one controller per manager, but sometimes there can be more. Next, the factories create models when a new one is needed, and the controllers are mostly made up of static methods or functions that essentially take models as parameters, modifies their state or properties, then returns the updated model. Sometimes they broadcast events as well. Speaking of models, those usually represent one thing, like the player or an item, and are usually made up of two parts, states and objects. States usually contain data that informs the controller of the model's, well, state. This could be anything from booleans like is jumping or is crouching to values like a movement speed modifier. The object, on the other hand, is actually shorthand for scriptable objects. Those contain persistent data that the controllers refer to when modifying or performing an action with a model. For example, a player's base speed would be found in its object, while a speed modifier that was applied from a power-up would go in the state. So let's say I have three managers, level, camera, and player, and Unity's input system broadcasts a new event, like the jump key. The managers all listen for input events, but only the player one reacts to the jump key event. It then passes the player model over to the player controller, which it manages, and the controller then updates the model's is jumping state to true and performs the jump action before returning it to the manager. In some projects, my scene can be practically empty simply because everything is added in programmatically via the scriptable objects and factories. It's just my way of working though. I don't think I'd recommend doing it this way normally, however, mostly because doing it like that kind of defeats the purpose of using an engine like Unity that has a drag and drop component-based interface to put your scenes together. Take advantage of that. Once the theme was announced and I was done brainstorming, I immediately jumped into development. Before putting anything whatsoever into the scene, I had to establish my mechanics. I figured I'd test those out via the Inspector UI as a quick proof of concept, as opposed to wasting too much time putting things together for playtesting in the scene. Luckily, I have access to this really great tool called Odin Inspector that I use to create custom inspector elements and interfaces super rapidly. So I add a list to contain the ingredients, made a function that randomly generates a solution from the list of ingredients, a function to add an ingredient to the cauldron, a function that checks the added ingredients and prints out how many I got wrong, right, or right but in the wrong position in the console. And easy peasy lemon squeezy, it works. Wait, okay, no, hold on. Okay, now it should work. Okay. I think I'm doing something wrong. It's always choosing the same 3 ingredients as the solution. Why is this not working?
Walk out the door, you see someone that you know and they ask you how you are, and you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Oh, I forgot to give the ingredients different IDs.
Dumbass!
I just had to fix this real quick and then...
It says you win, lol. Yay, video game! Video game!
Okay, so now that I have a functioning ingredient system, I have to implement the second mechanic. Curses! Or I could just not do that, waste time putting together a scene, and then put in the curses when I only have a couple hours left. Yeah, I think I'll do that instead. Okay, seriously though, I needed a break from programming, so I figured I'd start setting up the scene. I knew I wanted the game to be 3D, but I'm not a modeler, so I couldn't really create any of the graphics myself.
Loser.
Fortunately, the Unity Asset Store has a ton of models and visuals ready to be used. There are a lot of free ones, and I've also accumulated a bunch of paid ones over the years, so I could finally put them to use here. I started by plopping down a plane to use as the floor and gave it a simple stone material. Right there, I knew that using different models and textures from different creators in the asset store meant that the game would have a very inconsistent look if I kept everything as is. And since I didn't want to spend too much time on setting up the scene, I decided to simply slap a PS1 style shader on all the materials and reduce the textures down to very low resolution. That way,
Makes everything look consistently bad.
I then finished up the scene by placing a table, some chairs, the cauldron itself, some rudimentary lighting, and a variety of props to populate the table. The shader I use also has an animated version where it just moves the texture on the X and Y axes, so I thought of using that to simulate a bubbling potion inside the cauldron. I simply used a low resolution lava texture, colored it green, placed it on a sphere, and put that sphere in the cauldron. Nice!
It looks like accurately like a PS1 potion would probably look like. This was not like my original intention when trying to make it swirl, but that's how it turned out. So it's doing this thing where it like speeds up as it gets to the corner of the texture, and then when it loops back to the start of the texture, it slows down. It looks like it's constantly like bubbling.
I then added some quick walls, set up the camera using Cinemachine, and went right back to programming. Here's a quick list of all that's left to do.
That's a lot of damage!
The first thing I had to set up now that I had a scene was actually instantiating the ingredients. Of course, normally you'd want to use object pooling for this, but this is a game jam game and I was working solo, so I just skipped doing all these kinds of optimizations. I added some invisible walls around the table so the ingredients never fall off, and added a spawn point above the table, so I figured the ingredients could spawn from off-screen above the camera, then fall down onto the table. Then, when you add an ingredient into the cauldron, a new one respawns to take its place. Yes, I actually spawned a new one instead of just moving the one I already instantiated. Shut up. That's because the solution could contain duplicate ingredients, or actually be all the same, like apple, apple, apple. I then quickly created one ingredient prefab and assigned it to all the objects. Ta-da! Okay, they kind of all just fall in the same spot. Maybe if I apply some random forces to them so they fall in random directions when spawning? Hold on, I really don't like the texture on the cauldron. Let me fix that real quick. Okay, so I added the forces and now, okay, still not as nice looking as I thought it would be. Oh, they're all colliding with each other when spawning, and that probably affects the direction and forces I'm applying to them. I'll just give them an offset time when spawning by using a coroutine. Ta-da! Oh, hold on. Ta-da! Now, we set up the hand and the actual player controller so I can play the game without using the buttons on the inspector. I just threw a cube in there and made it follow the position of the mouse. And
Okay, no. Not quite. Not quite. Oh no, it's gone. The hand is gone.
hold on. Okay, it's working now. I had a bit of a hard time with this for some reason, so the movement is a little staggered, but again, game jam game. Man, I still don't like how that cauldron looks. Give me a moment. Okay, where was I? Oh, right, the hand. I adjust the camera so it stays fixated on the hand and slowly eases towards its position. I also raised it a bit to get more of a top-down view because it was difficult to see where you were aiming from the previous angle. I asked my wife to rig a hand model for me so that I could animate it closing and opening in Unity when you pick up and drop ingredients. Neither of us have used Blender before, so this took a lot of time. At one point, she almost had the rigging down, but it just wasn't working right. I gave it a shot myself after following a couple different YouTube videos and guides, and finally, something that looks passable. I plopped that in Unity and wow. Animating in Unity is not as easy of a task as I thought it would be. Look at all this, what even is going on here? Nope, time to ask for some help with this on Discord. Okay, while that's being done, I'll get back to the code. I'm just going to assign all the ingredients to a layer and then have a raycast shoot down from the hand that only checks for collisions on the ingredients layer. A simple raycast was a little too accurate though, so I switched that out with a sphere cast. I figured doing it that way would also allow me to change the radius of the sphere cast to change the difficulty. A smaller radius meant you have to be more precise when picking up ingredients. This could be one of the curses. By the time I get to implementing curses, I totally forget about all that though. Oh well. I noticed that because of the camera's perspective and field of view, it's difficult to figure out exactly where above the table the hand is positioned. That's a future Andrew David problem though. Hi, I'm future Andrew David. So I figured I could add some kind of indicator on the table below the hand, or maybe a cylinder of light that goes from the hand down towards the table, so you know exactly what ingredient you're hovering over. I started out by trying the cylinder of light idea, and it didn't look quite that great. I then remembered I have that magical effects pack sitting in my library on the asset store, so I got that and started playing around with it, until I found something that worked well. This ring on the table is clear and not too in your face, so I went with that. So next was picking up ingredients and dropping them in the cauldron to trigger the ingredients added method I wrote at the very start. Once the hand's sphere cast collides with an ingredient and you hit the left mouse button, I simply set the ingredient's rigid body to kinematic and move it up to a specific point underneath the hand. I then added a collider inside the cauldron that only collides with objects on the ingredients layer. Once the collision is triggered, the ingredient is destroyed and an added to cauldron event is broadcast. The manager listens for that event and calls the add ingredient method. If the number of ingredients added is equal to the number of ingredients in the solution, it automatically gets mixed and either tells you what you did wrong, triggers the win state, or triggers the you lose state if that was the last available attempt. I also added a trigger zone around the area where ingredients hang out. The hand can only drop an ingredient it's carrying if you are within that zone. This is to avoid having players accidentally drop ingredients off the table. Okay, now that that's done, I started creating the other ingredient prefabs. Up until that point, they all use the same Apple model. There. And now it's finally time to start implementing the consequences. Actually, wait, I still don't like how that cauldron looks. Okay, there. Whatever. I wanted two types of consequences, ones that affect the player, as in the hand and its controls, and ones that affect the camera. So I went ahead and set up the default player state. I then assigned that state object to the consequence. Then created a bunch of that consequences. I have a consequence that actually sets all the values associated with the object and add them to the player's active state. Since all the values are set to 0, except for the speed, only the speed will be reduced. And now, the hand moves slower. Doing it that way would allow me to create a whole bunch of different consequences super fast. The consequence object itself has a stackable boolean and a maximum stacks value. I used that for the hand enlargement consequence, so the first time it's triggered, the hand doubles in size, and the second time it's triggered, it doubles in size again, essentially making it 4 times its original size.
That's quite big.
I then did the same thing for the camera, but instead of having values to change, I simply made it enable and disable camera effect components that I've pre-attached to the camera and set to disabled by default. I got those effects as part of a pack I bought from the asset store way back in 2014. I then simply assigned all the consequences to the level manager and had the level controller pick a random consequence from the list when you put in the wrong ingredients. It then broadcasts a consequence event along with the consequence model as a parameter, and I have both the player and the camera managers listening for that event. Once they hear it, they each check to see if the consequence attached to the event is for the player and the camera, and whichever one it is relevant to will continue to apply the values, while the other one will dismiss the event. Now it was time to work on the UI a little. I wanted all the UI to be in-game. After all, the only thing I needed is a way to inform the player which ingredients they've already put in the cauldron, show them a history of all the previous attempts, tell them how many attempts they had left, inform them of the number of ingredients used in the solution, and show them how many ingredients they got wrong, right, and right but in the wrong order in the last attempt. Okay, that's more information than I thought. How about I just slap all that crap in a book and maybe list the ingredients currently in the mix using small bubbles beside the cauldron or something. First, download a book from the asset store. Thanks Robotic Rainbow Studios. Now, to remove all that text from the texture, place that in the scene, and voila! Now I just have to make it actually do stuff. Let's start by setting up a UI canvas. The idea is to have a separate camera look at the UI and then have that camera render out to a render texture, which I'll then place as a material on a quad on top of the book. So whatever I add to the UI canvas will appear as though it's written in the book. I figured I could have a different shape represent each of the types of results. Pink circle is correct ingredient in correct position, green square is correct ingredient but in wrong position, and red X is for the number of wrong ingredients. The circle X square pattern reminds me of the PlayStation controller, so that inadvertently works with the PS1 aesthetic. The maximum number of attempts you could get in the easier levels would be 10, so I set up one row for each attempt. Then, within each row, I put in the counter shapes and then slots for the ingredients to appear in. I had one version with 3 slots, then one version with 4, 5, and 6 slots. Those will be enabled and disabled depending on the number of ingredients the solution uses in the level you've reached. I also made all the rows invisible, so they only appear once you've used an attempt, to avoid cluttering up the UI. I did all this manually rather than programmatically like I normally would, simply because it was quicker and I don't need this to be modular or scalable since, once more, it's just a game jam game. Instead of creating a graphic for each ingredient to appear in the UI, I thought it would be cool if I simply used the actual ingredient prefab and made it spin randomly. I used DoTween for that and all other tweening and easing in the game. Next, I took a quick break from the development to come up with a name and logo for the game. This was towards the end of the second day, so I figured that would be a decent way to wind down for the night. Never mind! I had assigned my wife the task of finding sound effects, and she decided to give those to me just as I was wrapping up. I couldn't help myself from playing around with them in Fmod in order to start integrating them into the game. I kept it simple though. I put a bubbling liquid sound for the cauldron with a range so it sounds weaker when you're farther from it. Then a sound for successfully guessing a solution, and one for getting the ingredients wrong. And finally, when an ingredient drops on the table, it plays a squishy wood knocking sound at a random pitch, so it sounds a little different each time. Good enough. This took me a whole hour.
Wow.
I then slapped the logo on a separate UI canvas in the game, set up a rail for another virtual camera to ride in a circle around the table, made that camera look at the cauldron, and boom, main menu, done. On the final day, I integrated the book UI into the game so it actually functions. Whenever you mix in the right number of ingredients, a new row in the canvas is enabled and then updated to show the ingredients you entered and what you got right and wrong. It's a little ugly, and I'm sure I could do better, but I didn't have much time left, so that's just how it was going to have to be. I then wrapped up by adding some better lighting and some more props around the room so it looks more lived in and so the main menu camera has something to show other than a cauldron on a table. I added some finishing touches like a button on the main menu to start, one line of story, and one line to explain how the game works. I made sure the game shows the story and tutorial before the first level only. I then added a single text UI element that tells you when the difficulty has increased, and used that same element to also inform you the name of the curse that's just been applied. I then gave all the curses names, obviously. This one's my favorite.
Oh my god!
Oh, speaking of difficulty, I forgot to mention how I handled that. Initially, I just had the number of ingredients used in the solution, the number of ingredients on the table, and the number of attempts you get change every X amount of levels. But then I decided to just hardcode all the levels using scriptable objects instead. The game selects the one at the top of the list when starting and then moves down the list as you progress through the levels. I then created a cursor by taking a screenshot of the hand and throwing it in Photoshop. I used that same cursor graphic as the game's icon because why not? I also added a graphic for when you lose, and I added some particle effects using
It particle system.
And finally, I wrapped up by doing some last minute bug fixing, like the hand would stop moving entirely when the second stack of slow-mo consequence was triggered.
Yep. Once the slow motion is applied.
And there you have it, an entire game in 48 hours. I mean, crappy and probably very buggy, but a game nonetheless.
The ordeal.
Okay, this video turned out to be much longer than I had expected it to be, so I'm going to keep this section short for this one. I'd like to finally talk about scriptable objects. You'll notice that throughout this video, I've mentioned the use of these, and some of you may already know what those are, but I figured I'd talk about them anyway since I find them so useful, especially for quick prototyping and game jams. Keep in mind that I'm specifically referring to them in the context of Unity here. Scriptable objects are essentially containers that have specific values assigned to them. For example, an item scriptable object could have a name, size, and icon value. What sets those apart from simple models, however, is the fact that in Unity you can create instances of that scriptable object and assign them persistent values. Once I create it, I can then give it a name for Unity's context menu, then go to Unity, right-click in the project and select New Item. This will create an instance of the item that you can then give a name, size, and icon to. You can create as many as you want, thousands! And if you modify the scriptable object to add, let's say, a type, they now all have a type and you simply have to update that value on the objects themselves in Unity. In your code, you can refer to the scriptable object by its class name like any model. For example, I can write a function for using the item, like so, and then I can have that function check if the item's type value is set to usable before using it. Doing things this way will not only make it very easy for you to add new items in the future without having to write any new code, but it can also be a very useful tool for having other team members, like our game designer, add new content to the game without having to nudge you about it. Synergy! And that's it! I know this was a pretty long one, but I hope to refine the process over time, so the next video will probably be a little more concise. Until then though, I'd like to invite you to my Discord if you'd like to chat about game dev, and maybe follow me on Twitch so you can join in when I live stream my next game jam. All the links are in the description below.
If you like this devlog, then subscribe to this channel for more, and maybe give this video a like.
Thank you for watching, and see ya!